Hey guys, I'm Nick and welcome to the new Patreon tutorial. I apologize for sounding like this. I got a very nasty cold. Sorry. I will cut out all the cuts, so it should be okay. So today let's check out this particle smoke kind of RBD advection, because we advect the particles from the smoke, but also we emit the RBDs. Now we are here in Houdini, a super simple setup, just one HDRI, our setup, our backplate, which looks like this, and yeah, the rocks, and the rocks are the ones that I grabbed from the RBD morphing tutorial, which is basically a bunch of different spheres that you can see here. They are just like all different in terms of their radius. So if I go like this, you can see it here, and then I have the mountain node, which yeah, again displaces it a bit. Then super important thing is to actually add this labs auto UV or do any sort of UV unwrapping. In this case, method is set to UV unwrap, and pegging iteration set to 2, but you can use also like UV project, UV unwrap. I'm just using this labs auto UV here. Then we merge all of them into one big blob, and yeah, I also transformed it, scaled it down a bit, just because yeah, the size of the emitters is a bit smaller, so yeah, I needed to scale them down too. And yeah, now out rocks, and we have our rocks. For our backplate, it's just a box where I selected the size, and I made it by dropping group, and then you can go and just like select like this, click OK, and yeah, you will get it like this. But yeah, I just knew that you can also like click here on this little icon with the numbers and plane, and then it will display the kind of like the prim ID of each primitive. So I know that I don't need 2, 0, 5, and 1. So 1, 0, 2, 5 goes in that group. Then delete node, set to delete group 1, and check this enable checkbox for deleting by pattern. We just wanna delete selected group 1, and boom, it works. And then we reverse it, and yeah, that's our very simple backdrop. And yeah, now I think let's talk about this setup, because yeah, you can see we basically have two kind of logical blocks, which one of them being smoke and one of them being these RBD chunks. So first thing that we want to start with would be these two spheres. So both of them are set to primitive type polygon, both have a radius set to 0.5 and frequency set to 6. And for the smoke emission, we basically create two setups because we wanna make them collide, so they should have different velocities. And but anyhow, you need the mountain node with a offset. So basically you wanna displace your sphere like that. You can see here, something like you can see here. The offset is set to $time, so yeah. I think it's all default here in the in the properties of the mountain node. Absolutely same setup for the second sphere. And here we have our point velocity, and here we can check add velocity and set it to be 3 by z-axis, and you can see that we are kind of diagonally, but that's just because I have rotated this G off. So if we set it to be 0, you can see that it's just here. One sphere, second sphere, yeah, now they are perfectly horizontal. So in the point velocity, yeah, we basically add velocity to the left sphere. We add it to be 3 by z-axis, and for the right sphere we set it to be -3. So basically the velocities will make this emitted smoke collide in the middle here. I just checked this curl noise and curl noise animated. All the parameters here are default, and yeah, I don't know if you actually need to add that curl noise, but yeah, whatever. Then yeah, we drop a merge, and finally we can see both of them. Now we go to the Pyro source and we click this initialize and source smoke. It will automatically add density and temperature. Particle separation in my case is set to 0.03. Then we want to rasterize the fields that we have here, so density, temperature, and also the velocity that we have here, point velocity. So volume rasterize attributes, and attributes should be density, temperature, and V. And voxel size, you can see here that I again went to the Pyro source, copy parameter, paste relative references, and now whatever we set here in Pyro source, it will be automatically changed here in volume rasterize attributes. So yeah, I think here I haven't added anything. And yeah, then your default Pyro solver. For the setup, substeps, everything is set to 1. We actually don't need much more substeps. If you go crazy with this voxel size, which you can see in Pyro solver, I have also paste relative references, particle separation 0.03. If you will go crazy with this and set it to be 0.003, then maybe, yeah, you will need to increase the substeps, but for now it's working pretty decent. For the sourcing, I want to limit source range. Cycle length should be unchecked, but I don't want to emit anything after the frame 70. For the fields, I have decreased the dissipation, so we have a bit longer advection. For the shape, I unchecked the buoyancy. We just need disturbance and turbulence. For the turbulence, max octave set to 3 and turbulence set to 0.4, and for the disturbance, it's set to 0.2. Yeah, I think all other properties are default. And then we drop a file cache, and I was caching 120 frames. And if we visualize here, you can see how it goes. Pretty cool animation. Here you can see at the frame like 60, they finally collide. And you can experiment with these settings in the Pyro solver, especially with the shape and the turbulence, because maybe you wanna set it to be more like a I don't know, not like a nuclear mushroom, right? But yeah, less turbulent, so it's more like vicious. Because yeah, also here's the viscosity parameter, and you can experiment with that too. So I strongly advise just playing with this Pyro solver set to 0.03, or even you can set it to be 0.07, 0.05. It won't take you so much time, and 120 frames is not that shouldn't take that long. So yeah, just do a few tries. Do a few file caches with different settings and just see what works best. Now, after this file cache, we can drop our null out smoke, and now we can start building our RBD advection setup. So we have our spheres, right? And I'll be showing you just like on the left sphere example. So we drop a scatter, this one. Force total count could be anything, right? I want a really like a dense advection with a lot of small rocks. So yeah, that's why I'm using 100 in here for total count. And yeah, I'm coloring these into black and white. And maybe let's focus on this one, which is white, and it will be better to visualize, better to see. Anyhow, we need to drop a merge, and somewhere here you can probably see that we also have that black scatter. So yeah, then we do our copy to points with random pieces. So we drop an object merge out rocks. Here's our blob of all of our rocks. Then we do the connectivity. Attributes should be set to class, which is default. Then we connect this connectivity node to the attribute from pieces, and here piece attribute should be set to class mode random. You can also check this shuffle pieces. And yeah, this input from the connectivity, it goes to the right input from the attribute from pieces, and to the left input from the attribute from pieces. We plug our merge, so it looks like this here. And then we want to set the p-scale, random p-scale, and random orientation. So what we want to do here is drop an attribute wrangle and write down that we want to set our at orient attribute to be random based on the PTNum, and our P scale should also be random, but we want to remap it to be from 0.5 to 1 using the fit01 function. So function random gives us the random number from 0 to 1, but we don't want to assign that to our P scale directly, because P scale set to 0 will produce many different bugs in the RBD simulation. So we want to start with something normal. So 0.5 should be working fine. So that's why, yeah, we have our random function, but it is inside the fit01 function. So we remap whatever the value we got from our rand, we remap it to be in these boundaries of 0.5 and 1. And then, yeah, finally we can drop a copy to points and plug the connectivity into the left input and attribute wrangle to the right input. And super crucial thing here is this piece attribute, which should be set to class, because the class is that attribute that we used in the connectivity and attribute from pieces, and it allows us to have these beautiful rocks, which for now looks they look super smooth, but actually with a few proper bump maps, they will be looking like a decent small rocks. Yeah, and now, so because they are so irregular in their shape, you can see that, for example, here we have an overlap. So what we want to do here is to drop this attribute wrangle and write down that integer attribute that is called found overlap. So I at found overlap equals 1. We want it to be equal 1, and that basically means that RBD solver will try to push every RBD object to push it away from its initial position to in order to fix that overlap. Here you can see that some of them don't have overlaps, but yeah, we just basically apply that to every one of them. It's a tad bit easier than like actually calculating their size and all of that. So yeah, attribute wrangle found overlap equals 1. And then we go to the .NET. So let me zoom out a bit so we actually see both of them. And yeah, maybe we can go, it's Control D, background gray, save as default. Okay, cool. So yeah, we drop a .NET and we have our rigid body solver. What else? We have RBD packed object we have here, and we have our pop source. So yeah, let's just set up this little .NET. So we drop a rigid body solver. To the left input we connect RBD packed object. To the right input we can just connect the pop source. And to the like middle input we drop pop advect by volumes and pop drag. So let's go one by one. And for the RBD packed object, we have our obj geo copy to points 1, which is this one. Here in the initial state, I checked inherit velocity from point velocity, and also in the bullet data, I have this collision padding set to 0 because I actually don't want any collision padding. And of course the shrink amount. Then for the pop source should be set to all geometry and use first context geometry. So we use that same setup that we plug in the .NET, so that's our first context geometry. And the burst here should be set to something like, in my case it's impulse activation set to SF, which means simulation frame less than 60. So till the frame 60 we are emitting these rocks, and then the magic sauce here in the middle. So pop advect by volumes, and yeah, parameters velocity source should be set to outsmoke, field name val, advection type should be update velocity, and this velocity blend. Here you can see that from the frame 60, I will disable the simulation right now, but you can see that at frame 60 velocity blend should be set to 1, and at the frame 105, velocity blend is set to 0.3. So it's basically, you know, I want to drive them. Initially, I want to add much velocity, and then once they collide with each other in the middle of the frame, I gradually want to decrease the velocity and just like let them swirl in the air. And the same thing applies to this pop drag. You can see that at the frame 29, a resistance is set to 0, but at the frame 89, it's set to 3. So it's all done to basically gradually slow down our rocks. And of course, for our rigid body solver, sleeping time is set to 0. And that's the only thing that I actually changed here. After the dropnet, you can drop a file cache and yeah, again, cache these 120 frames. And here you can see how they actually collide. Should be looking pretty cool. And of course we wanna make it in slow motion, because then we can always speed ramp it and make it faster, so like normal speed in After Effects. So yeah, read time speed is set to 0.5. Output frame range 240, input frame range 120. Attributes should exclude UVs, so shift 6 UV will exclude UVs. And yeah, and here's the thing, right? Now they are backed, so we can render out these as instances or as mesh. For me, and it might be only because of the Mac and Redshift for the Mac, which is still in, like, I think early development. But basically, if we go here in our Geo tab and we go Redshift OBJ, you can go to the settings, render, instancing, and you can set it instance. You can check this checkbox here, instance sub-level packed primitives. So then it will instance your packed primitives. For me, this actually works worse than just actually unpacking. And then if you go with unpacking, you want to transfer attributes color, velocity, and UV, because we will need the color to differentiate two materials. We want to transfer velocity because our motion blur depends on velocity, and of course we want to transfer our UVs because yeah, we will be applying the materials, we need UVs. So yeah, here you can see that we have 11,000 packed geometry, so we will be using 11,000 instances if we go with this instance sub-level packed primitives. But believe it or not, it's actually faster, in my case, faster to calculate like 11 million polygons. I don't know how it works here, but yeah, just, I mean, dropping the unpack node and working with the polygon geometry rather than packed instances. And yeah, that's basically it. Let's check the light, materials, and redshift rendering. So rotation should be set to 40, I think. So yeah, let's enable the backplate. We don't need our rocks to be visible because we are also kind of like object merging them into geo. So our slide dome, just like a Photo Studio HDRI. Let me also maybe fire up the render just so we have it. Before we do that, just want to mention that I have my camera. Camera is set to vertical format with these two emitters being kind of out of frame, and then as we go it appears in frame. Yeah, let me start that render. So here's how it looks, and let me talk about let's talk about the materials, because there are a few things that we might want to discuss. Of course, we have motion blur also, so you cannot see textures that well. Maybe we want to uncheck motion blur for now. Then we go here in the render and just uncheck all of these just to be safe, and probably restart the render. Yeah, so the main thing here in the material network, yeah, our grid, and let me just name it correctly, grid material and rock material. All right, So our grid is basically just grayish and rough material. For the rocks, that's a bit more interesting here. So we have two materials. One of them being black and the other one being white. But both of them are utilizing noises for the colors and bump maps. So I'm using this RS noise, and in both cases it's set to somewhat similar colors for the coloring, because I don't want them to be like a black and white something. I want them to be just like with a bit of difference in coloring. If let's say for now I set it to be black and white, that sort of different pigmentation here with the noise. I also have, let's set this noise that goes into roughness, let's set it to be in the diffuse channel, and you can see that it's somewhat like light gray with a very subtle differences, and this goes into our roughness channel. Why it's more on the like white side, because I don't want any sort of really glossy surfaces on these rocks. But yeah, for the bump map, here is our, let me get this one plugged into the diffuse, and probably you cannot see that well, but it's very detailed, and let's maybe copy this camera to the camera 2, and if we enable and select our camera 2 here, obj cam 2, and here go to the camera 2, and really zoom in into one of these. And what do we want to select here? We want to uncheck the bokeh. So here you can see very detailed surface of our rocks. Let me zoom out a bit. Yeah, so here you can see that they are pretty detailed, and this level of detail is actually achieved using this bump map here at the height scale of 0.01. If we set it to be 0.1, you see it's really too much. It doesn't sound realistic or feel realistic to me. So 0.01 is somewhat what we want. Yeah, then our colors go into the diffuse color. It was somewhat like this. So yeah, this is more or less like the realistic rock texture with the noises. And yeah, the same thing goes to the white rocks. And then how we actually mix them, let me drag this to the surface. Here you can see I'm using particle attribute lookup and attribute name set to CD. What we want to do here is drop a material blender, and in the base layer we grab and plug our black rocks, and in the layer 1 we plug our white rocks, and we plug that into the layer color, like our white rocks material, and into the blend color of the layer 1. Then we plug this particle attribute lookup, which checks for the color. And because we have our particles black and white, the p-scale color is set to black and white, we can use that in that material blender. And if I probably restart it, now you can see that we have both of these materials. They are divided by the actual particle color. So yeah, let's check the motion blur again. All of this should be checked. And for the actual redshift settings, so I'm rendering 240 frames, rendering the camera 1, rendering PNGs. I think I'm using too many samples, but I was getting some noise when using less. So minimum set to 128, maximum set to 1024, overriding reflection and lights. Motion blur, of course, enabled, and deformation blur and incidence particle motion blur should be enabled, should be checked. Start set to 0.15 and set to 0.8. GI set to brute force and brute force 8 and 256. Yeah, I think that's it. Well, yeah. Alright guys, thanks so much for watching, and yeah, I apologize for sounding that bad, and obviously this tutorial went a bit slower because it's hard to properly explain things when you have a fever. But yeah, still, I hope that you learned a few new tricks, and if you have any questions, please don't hesitate to reach out, whether it be in Patreon messages or better in our Discord channel. But I'll be back with a new tutorial next week. Bye!